Welcome to Ground Control. It's time to take our XK A160 J3 Skylark Cub out for another test flight. Now, if you haven't seen the last test flight, you should take a look at it, because this is now a very aerobatic J3 Cub bush plane with a significant amount of power. This two-blade ABS 6x3 prop, this Gemfan prop, performs much better as far as thrust and efficiency than the original 6x3 prop I had on it. This is the one that I used for my bench testing. Alright, so I did carve out some additional foam because I have some lightweight 450mm 2S lipos that are high C, they're 80C, but they're very narrow and they're very long. And I wanted to put a little more nose weight on this anyway. So I carved out enough foam that I can now push the battery about 5mm, maybe 6mm further forward than I could before, which made room for those little 2S stick batteries. So I'll be able to fly with those now as well. But that should also add a little bit of nose weight. I'm not sure yet if, because I took a look at this motor, and this motor has, the way I have it mounted in here, it has a significant amount of down thrust, as well as right angle to counteract the torque. So I think it's still a nose weight issue. So I think being able to push that battery further forward than what I had it last time out, I think that may take care of that zooming issue where I was flying straight and level in the last test flight session, and I would go full throttle and ever so slightly it would climb. So we'll see today if it takes care of that issue. Also, after I had added the additional right angle to the motor last time out, rather than wanting to drift to the left a little bit with the torque of the motor, it was actually drifting to the right. I had added a little bit of mechanical trim to the right aileron to pull the wing over to the right a little bit, and I had forgotten about that. So it has a neutral amount of trim in it now. Both of the ailerons have a neutral amount of trim. I think that the right angle on the motor is right where it needs to be to counteract torque with the 6x3 prop. So we will test that out today too and make sure. I noticed that when I took it out, when I did rolls last time, that the rolls were just as fast to the right as they were to the left. The rolls were pretty symmetrical, and so that also tells me that I've got the torque of the motor taken care of with the right angle on it. So everything else is the same. I think I stated at the end of the last video when we came back to the HQ that I had dampened the rudder a bit. I had 100% dual rate in it. I kicked that back to 80% dual rate and then practiced some stall turns with it, and that worked out a lot better. The rudder wasn't moving as much as it was before, so it was a little bit easier to perform that maneuver. So let's take it out and test it out again. I think I may be golden on the setup now, and if I am, then I'll be putting together a setup file for anyone who wants to do this, and I will also give you guys a list of the components that I used for this, recommended components, so and see how much it would cost just to order the fuselage, the pieces of the fuselage without any electronics, and set it up the way I did. I'm guessing that that's probably going to be less expensive than the ready to fly version, and this is much better than the ready to fly version. If you watch the last video, you can see that. So I will see you out at the field. Okay, back out here with the J3 Cub after making a couple more adjustments to it. So let's see if we're golden on this flight. Launching. Oh, took off nice and straight.
Nice. Nice roll rate to the left. Nice roll rate to the right. They look pretty symmetrical to me. Nice big power loop. I think we may be golden on this. Alright, let's see here. See if, look at that. It's not zooming like it was before either. So yeah, I think that I've got plenty of down angle on the motor. And I think that it was still just slightly tail heavy last time. Look at that. Sweet. And that's going into the wind. That's crosswind. That's pretty good. I'm liking it. That's quite a bit of rudder I'm putting in there. I think I have an aerobatic bush plane. That's what I think. Alright, I think I like my throws. Yeah. And those are pretty axial, you know, for an overhead wing plane. Those rolls. Not bad at all. Alright, so let's cruise around a minute with it. Then we'll bring it in for a landing here. Got a crosswind again today, as usual. So let's bring it in from the opposite direction, away from the sun, so it doesn't look like a silhouette when I'm bringing it in. That's better than my last landing. I guess my practice has paid off. Alright, so I think, woo, it is slick out here. I think that my control surface, whoa, I am going to fall my butt out here. Wow, I can't believe how slick this gets with a little bit of traffic. Man, I'm going to walk over here in the snow. Alright, so before I fall my butt out here, I think that I am golden on my setup on this plane. And when we get back to the HQ, I will give you information on everything that I did. Show and tell tutorial on the modifications that I made. And then we'll talk about cost of converting the ready to fly into what I have now, which I'm very happy with. Much better than the stock plane, even though it's much heavier. And also what the cost would be involved if you bought all the replacement parts to put it together with the electronics that I used in it. I'll see you back at the HQ.
Okay, so what did you guys think of my plane? I thought it performed very well. I think I am definitely golden on this plane now. So I have it flying precisely the way I want it to fly. Being able to put a little more nose weight on it, bringing those batteries a little bit further forward, is taking care of the zooming that I had on it when I go full throttle. Taking the trim that I had out of the right mechanical trim I had in the right aileron. Now when you launch it, it takes off nice and straight. I have a very good roll rate on it to the left and to the right. They look very symmetrical to me, which tells me that I have counteracted the motor torque with the right angle, and with the zooming gone, I definitely have the proper amount of down angle in it. So at this point, what I'll do, because I've already created a setup file for this plane as it came stock, so I'll combine those two into one PDF. So there will be a setup file for this plane as it comes stock, and there will be a setup file for this plane with the conversion that I did on it, with the components that I have in it. My control surface deflections, expo, all that information will be in there. It is still very fat, so I was surprised at the slow flight capability that it demonstrated out there today, and I was making some pretty tight turns with quite a bit of rudder in it, going fairly slow, and never once did it attempt a tip stall on me. If you guys watched the previous test flight video where I performed 2 stalls with it, now that the balance is correct on this plane, it stalls the way it should stall. You know, if I slow it down and then pull the nose up, when it stalls, it just drops its nose and goes on. There's no drama to it whatsoever. That's the way I like it. It has a power system on it now, even though it's a very fat plane. It can pull through big power loops. You can do split S maneuvers with it. You can do rudder stall turns with it. And I was really surprised at how axial the rolls were, given that it's an overhead wing and it has some dihedral in the wing. I was very surprised at how axial those rolls were. So I'm really happy with that too. And that tells me that the balance is pretty darn good. I checked my transmitter, and the only trim that I have in my transmitter, other than sub trim to center up the control arms on the servos, is I have about 4 clicks of down trim on the elevator, and that's the only trim that I have in the radio. All the rest of it is mechanical trim. So I think if I disconnect the control linkage on the elevator and turn that plastic clevis in about 2 turns to bring the elevator down a little bit, I'll be able to take the elevator trim out of the radio as well, and then I will have no trim programmed into the radio other than the sub trim to center up the servos, and that is it. Okay, so my CG point on this plane, and I've got little dots marked here with magic marker. I don't know if you can see that on camera or not, but I measured the root chord of the wing, and it's approximately 95 millimeters in length from the leading edge to the trailing edge of the wing. And my CG point is 31 millimeters back from the leading edge of the wing. So when I put my fingers on those 2 dots and I have my flight battery in there, it balances completely straight and level. The tail doesn't drop, the nose doesn't drop. It's completely straight and level. It's a neutral balance on the CG, and that's what I like. And that's the way I have this plane balanced. I have a Racerstar 1407 3500 kV motor on it with a Gemfan 2-blade 6x3 ABS prop, and I like the power that I'm getting from that combination. I do have a new Racerstar motor that's on its way for review. It's the BR 1408 3600 kV, and I'm going to be, after I get the bench testing completed with it, I'm going to be testing it in this plane as well. I love these Racerstar motors, and with the length being 1 millimeter longer and 100 revolutions more per volt at 3600 kV rather than 35, I'm hoping that the 1408 3600 kV will give me even more thrust and efficiency than the 1407. What I'm hoping is it will produce more thrust, without pulling any additional amps. So we'll see how that turns out. I do recommend, even with the even if you're not going to make the conversion, I do recommend cutting out a bunch of that foam in the front so you can get those batteries further forward, because this plane is so tail heavy. The Ready and Fly version is so tail heavy, which is precisely why it wants to tip stall all the time. That plus having a tremendous amount of rudder mix programmed in with the ailerons, that's just a bad combination for creating tip stalls. So as you saw it flying today, and if you watched the videos from the last session, the stalls are very gentle and very predictable now. So I'm going to have a lot of fun with this plane. Now I went through and I added up all the components, all the repair parts for this, to compare it, the cost of building this with these electronic components as opposed to converting the Ready to Fly version. And it is a little more expensive. Last time I checked, the cost of the plane, the Ready to Fly plane, was $129.99, $130 roughly. So I went through and I added up all the components plus the electronics that I put in it, and it would cost $133 for me with the DSMX receiver that I have in it. So it's slightly more expensive depending on what receiver, what servos, what motor, and speed controller you pick out. Might be a little more expensive than that. But for $133, I'm going to have a lot of fun with this plane. And this $133 plane flies a lot better than some more expensive planes that I have. So I'll let you guys be the judge as to whether that is doable for you or not, because it does take some work to assemble it. You got to glue everything together, install the electronics, but it's cheaper than buying the Ready to Fly and then doing the conversion. Probably about $15, $20 cheaper than doing that. So anyway, I'm gonna leave you. I'm gonna put up some pictures that are going to show the material and the placement of everything that I did on the conversion. I'll have links to the components that I used for the conversion. And thanks for watching, and I will see you in the air.